Today I want to talk about when we're given a function and we are given a graph and being able to determine what the zeros are, but not just that, also being able to determine the multiplicity and what that multiplicity will do to the graph. How is that multiplicity going to affect our polynomial graph? So let's just start off with very basic information here. First, this is already in factored form. So from that, we can determine our zeros. Our zeros here are -1, -3, and 1. So setting that equal to 0, you get your zeros. What we also know is that the multiplicity for each of these zeros, here, this understood 1 is here. So that multiplicity for -1 is 1. We know that the multiplicity for -3 is going to be 2. And we know the multiplicity for 1 is also an understood 1. And we also know that using that multiplicity, if we add those up, we can get our degree. So our degree of this function is going to be 1 plus 2 plus 1, which gives me 4. Now, from here, how can this help us determine the shape of our graph? Well, we already know from previous videos, and if you haven't seen our videos yet for the end behavior, go back and look at that. But from previous videos, we know that we have a positive leading term and our degree is 4. So we already know that our end behavior is up, up. And that helps us at the ends, but it doesn't really help us in the middle. That's where the zeros come in. And so we know that we have a 0 of -1, that one's right there. We have a 0 of -3, that one's right there, and a 0 of 1, and that one is right there. Now, I'll need to talk about the relationship of the zeros and the multiplicities with respect to the graph now. So in many cases, our multiplicities are just 1, and we end up with a fairly normal shaped graph where maybe it's just going like this, okay? Notice though that this one's doing something different. Right here, we have it touching the x-axis, but then it's going back the other direction. So it's almost like it touches it and it doesn't want to cross it. So we know that that's going to happen by looking at the multiplicities of the zeros. If our multiplicity of the 0 is odd, let's look at our 0, -1. Right here, we have the 0, -1, and that's odd. So you can see that the graph actually passes all the way through that 0 and continues in the same direction. So it's going down, it's continuing to go down. So if it's odd, that's what's going to happen. It's going to pass actually through the x-axis and continue going in that direction. Let's look in and confirm that with our 0 of 1. So our multiplicity for that is odd. If we look at our 1 right here, then we see that we have this going up and it's continuing to go up. But when we have an even multiplicity, something kind of strange happens. At that 0, in this case it's -3, the graph is going to touch the x-axis. It will come down, touch the x-axis, and bounce back the other direction. So that is this point right here, when it has an even multiplicity, is actually going to be a turning point. It will be a turning point on the x-axis. So one more time, if it's even, it does what's called a bounce. It continues, it goes down, but then it changes direction to go back up. All right? So this is helpful for us if we wanted to work in reverse. So let's just say I did not give you the function, and let's say I just gave you this graph. You would be able to look at the graph and say, okay, this point right here passes through, so that multiplicity is 1. This point right here passes through, so that multiplicity is 1. This point right here is a bounce, so that multiplicity has to be even, and the smallest even number is 2. So if I wanted to ask what was our least possible degree here, then I would have to say that this would be 1, 1, and 2. So our least possible degree would have to be 4. Now, I want to say real quick, if you're working backwards like this, we're not always sure that our multiplicity is 1. What we are sure about is that the multiplicity has to be odd. So what I could write right here is this is odd, which again, the smallest odd number is 1, smallest odd number is 1, and that would be my least possible degree of 4. But what it really could be is a 3. I could have a 3 multiplicity there. I could have a 5. And with the even, I could have 2, 4, 6, and so on. Okay, so if I'm working backwards and maybe I don't have all of this up here, then all I can do is tell the least possible degree. I can't tell the actual degree without more information because I don't know that yet. But what I can do is just look at my my multiplicities to help out with that. If you go and look at my other video on turning points, we also talk about turning points and how to determine the least possible degree with that. So that would be helpful as well. But this becomes handy whenever you're maybe given a function and you're given some options and say, graph this. And then you can look and see what are my zeros and which one of those zeros is going to be a bounce. Maybe there is one and maybe there's not, but this will help you determine that.